Alright, so we've been doing derivatives for a while now. Okay, so we've seen product rule, we've seen power rule, we've seen quotient rule. We're starting into chain rule, and chain rule has a diverse way of doing it. We can do it explicitly, splitting it up into the two functions. We have the inside-outside rule, but then we also have these formulas for like power rule that we first learned that we can actually embed the chain rule into it. Okay, so basically if this is our derivative, let's say that this wasn't just x. Let's say that this was like this, u to the n power. U in calculus basically tells us that it's a function. Okay, so the power rule with just x to the n, you get n, you move the power out in front, and then you subtract 1 from the power. Now, if we did this like we first learned it, where we actually try to take the derivative of a function to some power, we would split it up as u being that function, and then y equaling u to the n power. And then this u would be whatever this f of x is, this function. Okay? And then what we would do is we would take the derivative of both of these, and the derivative of u to the n, that would be our u n times u to the n minus 1 power. And then we'd multiply that by the derivative of this, which is the derivative of u, which would be our, say, f prime of x. And then we'd multiply those, and this explicitly being chain rule is that formula right there. Okay? So we can do this to almost any of our formulas. So for instance, looking at this next problem, I've got e to the x squared plus 4. Now, our original derivative of e to the x is e to the x. Our chain rule variant of it would be, say, e to the u. And the derivative of e to the u would be e to the u times the derivative of u. Because the du is the derivative of the inside function, just like when we do inside-outside rule. This is the derivative of the inside, this is the derivative of the outside. But I've wrote it in a formula to make it really easy for us. So for instance, this, following my formula, y prime is going to be equal to, this is e to the u. So using this formula right here, I'm going to get e to the x squared plus 4 times the derivative of that, which is 2x, using it formula style. And this is e to the u times du. So any of our formulas can be rewritten as a chain rule formula. Same thing with cosine. D over dx, the derivative of cosine x is negative sine x. So the chain rule variant of it would be cosine of u, and the derivative of cosine of u would be negative sine u times the derivative of whatever u is. So again, over here, following the formula, y prime, this is cosine u, so you get negative sine of 6x cubed times 18x squared, which is the derivative of the inside. Now, this one here, we have product rule and we have chain rule. We know we're going to have to do chain rule for natural log. So what I'm going to show you is this is original derivative for the natural log of x. You get 1 over x. The chain rule variant of it, which would be the natural log of u, would be 1 over u times du, or the way I write it always is du over u, which is going to help us tremendously when we go to take this derivative. So again, we're doing product rule because it's this times this. So y prime equals x, which is 1, ln of 2x plus x times the derivative of ln of 2x, which basically you just take whatever's inside, put it on the bottom, and whatever's on the bottom, take the derivative and put it on top. And that's the derivative of natural log. So any of these formulas, we can use this chain rule variant of them. So if we have a formula, we just plug in u for x, and then when we take the derivative, we just have a du tacked onto the end. And then the last one is basically the one we used up there, e to the u. So the derivative of e to the u is e to the u times du. So y prime, again, we're doing chain rule here. So it's 2x e to the pi x plus x squared times now the derivative of that, which is e to the u times the derivative of u, which is pi. And that's our derivative. So using these formulas or knowing these formulas ahead of time really help you when you're in crunch time, so that you don't have to actually do a process. It's just pulling it from memory. It's not any different than when you were in Algebra 1, Algebra 2, or Algebra 3, and you were just using your multiplication tables. If you have to stop and think about something else in the middle of a problem, it makes it that much more difficult versus just knowing something and being able to apply it right away. Okay? When you start adding processes into processes, then that makes the formulas or the problems you're working out more difficult.